In the lecture series on introductory mechanics, we are at lecture number 3, and today we are going to talk about Cartesian coordinate system and rotation of axis. As you know that for any measurement we need a reference, and we can constitute that reference from coordinate axis, and we call this rectangular coordinate system because the angle between all the axes is equal to 90. This is also called Cartesian coordinate system. So let's make such a rectangular coordinate system by choosing an horizontal line and call it an x-axis, for example, and then choose another line along vertical axis and call it y-axis. And since we live in 3 dimensions, so we need a line for the 3rd dimension as well. Let's call it z-axis, which is perpendicular to both x and y. And the point where all these 3 axes meet is called origin and denoted by O. Now this is a reference which we can use for making any measurement, but we can include negative values as well. For example, along horizontal we can have negative x-axis, which is on the left of the origin conventionally, and then we can extend the y to the negative axis as well by downward minus y-axis, and similarly z will get its negative z-axis. So now this is a complete reference system called frame of reference, for which we can use for making any measurement. But before making any measurement, we need to calibrate this system as well, and by calibration we mean that we have to put marks on these axes. For example, we can have equal intervals, and these numbers represent the intervals, and this can be in any units, for example in centimeters or millimeters or meters, depending on the situation. And a similar marking can be put on the y-axis and z-axis as well, and the origin, or the point where all the 3 axes meet, is labeled as 0 point. So this Cartesian coordinate system or rectangular coordinate system is now ready to make any measurement with respect to it. But at this point, question arises that whether this Cartesian coordinate system is unique, or we can have similar other coordinate systems as well. The answer is that it is not unique, and we can actually have infinite number of coordinate systems. They differ not only in type of the system. For example, we can have spherical or cylindrical coordinate systems, but also in rectangular coordinate systems or Cartesian coordinate system, we can have infinite number of other systems as well. But all these systems are equally good. That means that measurements made in one frame of reference is equivalent to the measurement made in another frame of reference, and there is a connection or relationship between these measurements. So in order to develop these relationship, we will take a simple example, and we will take 2 rectangular coordinate systems. Let's take the first one and call it xy coordinate system, and for simplicity we have ignored the 3rd dimension. That doesn't mean that there is no motion or there is no measurement in 3rd dimension, but for our illustration purpose it is just ignored over here. Now let's take point P and assign coordinates xy to that point P, which might denote its position with respect to this frame of reference. And here x means that a line parallel to the x-axis, which will be perpendicular to the y-axis actually, and this gives us the x coordinate of this point P. And similarly, we can draw a line from point P on the x-axis and parallel to the y-axis, and this gives us the y coordinate of this point P. Now we can choose another coordinate system, which is also a rectangular or Cartesian, and which is slightly rotated with respect to this xy system. Let's call it this x prime and y prime, and it is rotated through an angle theta with respect to this xy system, and now we have another frame of reference which is called x prime y prime. In this frame of reference, the point P gets coordinates x prime and y prime, and in similar fashion the x prime would be a line parallel to the x-axis and perpendicular onto the y-axis, and the y prime coordinate would be the line parallel to the y-axis and perpendicular onto the x prime axis, as you can see over here. So now the question is that whether can we have a relationship between the old coordinates, that is xy, and the new coordinates, that is x prime and y prime, and the answer is yes. In order to derive this relationship or transformation between xy and x prime y prime, we need to first understand this geometry a little bit. First, let's do some labeling. Let's call this point S, which is a point where the perpendicular from point P meets the x-axis, and also this point Q is it's the perpendicular from point P onto the x prime axis, and similarly we can have from point Q a perpendicular on x-axis which is meets at point T, and then on y-axis which meets at point R. Now our geometry is ready for derivation, and what we first take the horizontal axis, and here you can see that this equation holds, that is the OS line is actually equal to the OT line minus ST line. And now important point over here is to note that ST is actually QR, because ST is parallel to the QR, so we can replace ST with a QR, and the reason is that we will be using this triangle, right angle triangle here to later relabel QR. So so now consider this triangle, this big right angle triangle over here, and see that this triangle OQT has this angle theta has a base OT and a perpendicular QT. So as you all know that from trigonometry that that OT is actually OQ cos of theta, that is the projection of OQ on x-axis is OT. So we can now replace this OT with OQ cos of theta. But before, you can also notice over here another triangle, this yellow triangle, which is a PQ and R triangle. And in this PQ and R triangle, we would also have the base, because this is this angle we are using. So we also will have a base which is PR and perpendicular which is QR. So as I already mentioned that over here we can replace OT with a OQ cos of theta, because the OT is a base of OQ in this right angle triangle OQT, and QR is this QR is actually perpendicular in this smaller triangle. So QR is actually PQ sine of theta, because this PQ is this perpendicular PQ sine of theta. But then you can easily see that this OS is actually X, because this from perpendicular where we have drawn. So this OS is the X of coordinate of the point P, and this OQ, which is parallel to the X prime, is the X prime coordinate of the new frame of reference X prime, and cos of theta is in its place, and PQ is actually Y prime, as you can see over here. This is a Y prime, so we replace PQ with Y prime and sine of theta. So this is the first relationship we have derived between the new coordinates and old coordinates. So old coordinate X, that is horizontal, can be is equal to the X prime cos of theta minus Y prime sine of theta. So now we turn to the vertical part. On the vertical part, you can see that PS is equal to PR RS. Over here you can see that this PS line is equal to PR line plus RS line, and then we can replace RS with QT, because this RS is parallel to this QT line, because we want to use this big triangle. Therefore RS is replaced to the QT, and then this PR is actually PQ cos of theta, as we have already mentioned that this is the base of this smaller yellow triangle. So PR is a P Q cos of theta, and similarly this OT is in bigger triangle is OQ sine of theta, that is the vertical component. And then we can replace PS with Y, because this was the Y component of the point P in XY coordinate system, and PQ with Y prime, and similarly OQ with X prime, because this is parallel to the X prime. So this is equation number 2. So in this way we have derived from this geometry the relationship between the old coordinates and the new coordinates. And now the question arises that whether it is possible to have the inverse of these transformation equations, and the answer is yes. But for the derivation of the inverse of transformations, I will not use the geometry, but I will use the algebraic method, and in which we multiply equation this one with the cos of theta on both sides and each term, and we get this equation: x cos of theta x prime cos square of theta and minus y sine theta cos theta. And then we multiply equation 2, this one, of the y component with sine of theta, and get this equation. And then what we can do is add them together on both sides. So left sides x cos theta and y sine theta are added to get this one, and the first term x prime is taken common, and cos square theta plus sine square theta is in the parenthesis, and the last term cancels out. But we know that cos square theta plus sine square theta is equal to 1. So this is the new relationship between new coordinates, that is x prime and y prime. So it is a relationship between x prime and x and y. That was the old coordinate system. And similarly for the y prime, what we can do is to reverse the process and first multiply equation 1 with the sine theta, and equation 2 with the cos theta, and rather than adding we can subtract them, and while subtracting we will see that this first term, this term will go away, and then we will get minus y prime common and get cos square theta sine square theta in the parenthesis, which is equal to 1, and in this way we got the inverse transformation for y component. So in summary, you have seen that how the rotation of axes have another coordinate x system, and how these measurements of the point P can be related. So once you know the one coordinate system measurement, you can readily transform it into another coordinate system if you know the value of the angle theta. But they are both equally good, but according to the laws of physics, that the measurements are independent of the coordinate system. So whatever you measure will not change the reality about point P, but we on our own choice we can choose any of the coordinate system, and then if we need, we can translate this measurement to the new one. With this, I thank you all.